At around 4:30 a.m. on November the 27th, 1942, the perimeter of the Toulon naval base collapsed. German panzer tanks smashed through the arsenal gates and raced toward the docks. Their objective was to seize the major warships concentrated in the harbor, one of the largest naval forces still under Vichy control. The French Navy lay at anchor, cold and dormant. The tanks had speed and firepower, but the French officers held a different kind of weapon. It was a prearranged signal that required no radio and no debate. On the flagship Strasbourg, Admiral John de Laborde issued the order. It was a terminal command: scuttle, scuttle, scuttle. This decision triggered one of the largest deliberate self-scuttlings in naval history. It wasn't meant to trade fire, it was meant to erase the fleet from the strategic board. Within about an hour, more than 235,000 tons of warships and auxiliaries were burning, capsizing, or sliding under the oil-slicked water. The primary mechanism of this destruction was the sea valve, the through-hull fittings that connect a ship to the sea. Under normal operations, these intakes are protected and monitored. On this morning, they became the execution method. Sailors descended into the lower spaces, opened seawater intakes and other flooding points, and shut down the pumps. Seawater surged into machinery spaces and compartments. In some ships, cold water met warm metal and fractured piping. In others, the damage was simply weight and time. But the French engineers knew that sinking the ships was not enough. A wreck in a protected harbor can be raised if the hull remains reasonably intact. Even a drowned battleship can be sealed, pumped out, and made to float again. To ensure the fleet remained dead, the crews targeted the anatomy of the vessels. They moved beyond simple flooding and began systematic sabotage of key machinery and fire control equipment. Among the most valuable targets were the propulsion reduction gears. A reduction gear sits between turbines and propeller shafts, translating high rotational speed into usable torque. It is a precision component difficult to replace quickly in wartime. The French crews rendered these critical parts unusable, turning a refloated hull into a ship that could not easily steam again. This was a calculated technical decision. A hull patch can be welded in days. Rebuilding the heart of a propulsion train can take months, specialized tooling, and stable supply lines. By crippling the machinery, the French made it far harder for any occupier to return the ships to service. Even if the water was pumped out, the fleet would remain at best a collection of powerless hulks. On the decks above, the crews disabled main guns and the delicate instruments that aimed them. Breach mechanisms, rangefinders, and optical fire control gear were wrecked or removed, ensuring that any surviving batteries would be unreliable and dangerous to operate. The heavy cruisers Alcieri and Duplay were set on fire, the crews using fuel and other accelerants to make sure the flames took hold. By the time the German infantry reached the gangways, the fleet was gone. 77 vessels, warships, submarines, and auxiliaries were already surrendering to fire and rising water. The battleship Strasbourg remained upright, her keel resting in the mud, but her internal spaces were drowned. The battleship Dunkirk, already immobilized in the arsenal for repairs, was flooded where she sat, her machinery ruined. Clouds of black smoke from the burning cruisers drifted over the city, obscuring the sun. The immediate tactical crisis was resolved. The fleet had not been captured, but the laws of physics do not respect political gestures. The ships were not gone. They were merely submerged in shallow, dirty harbor water, metal, bronze propellers, and fuel oil still sitting there in the mud. And as the smoke cleared, a new set of eyes looked at the wreckage not as a tragedy, but as a resource. The Germans had failed to seize a fighting navy, but the Italians were about to arrive with a different plan. They did not see a graveyard. They saw a salvage yard. The harbor at Toulon had become a shallow grave for 77 distinct steel carcasses. The visual impact of the morning after was not one of emptiness, but of chaotic industrial clutter. Masts poked out of the water at impossible angles. Hulls lay exposed like beached whales, their red anti-fouling paint baking in the winter sun. Wreckage blocked basins and quays across the naval base, turning the port into an obstacle course of steel. The orientation of these wrecks was determined by a ruthless application of hydrostatics. The ships that settled upright, like the battleship Strasbourg, did so because their immense width and flat bottoms allowed them to land on the harbor mud before they lost stability. They were heavy, stable platforms that simply sank vertically until the keel met the resistance of the earth. But for the destroyers and light cruisers, the physics of flooding had been far more violent. Many of these vessels lay on their sides or completely upside down. The culprit was a phenomenon known as the free surface effect. When a ship is intact, its stability relies on the cargo and ballast remaining stationary. But when water partially floods a compartment, it is free to slosh back and forth. This moving mass of water acts like a shifting weight. As the ship rolls slightly to one side, the water rushes in that direction, exaggerating the roll and preventing the vessel from snapping back to vertical. This movement destroys the delicate relationship between two invisible points, the center of gravity and the center of buoyancy. The center of gravity is where the ship's weight effectively acts. The center of buoyancy is where the displaced water pushes back. When floodwater sloshes freely, it creates a virtual rise and shift of the ship's effective center of gravity, shrinking the righting arm that normally pulls a hull back upright. Once the main deck edge dips below the surface, the roll can become irreversible. The ship capsizes, snapping masts and crushing superstructures against the seabed. For the Italian Navy, the Regia Marina, this chaotic scene represented a strategic opportunity. Under wartime shortages and blockade pressure, the wreckage offered steel, equipment, and, if salvage succeeded, hulls that might be put back to work. When Italian engineers arrived at Toulon, they started measuring, listing, and triaging the wrecks like a job that had to be finished. In early 1943, the Italians formalized their claim on the wreckage. A dedicated salvage authority was set up to manage the work at Toulon. Its mandate was twofold. First, it had to clear channels and basins so the port could function under occupation. Second, more ambitiously, it sought to refloat selected major units and assess whether any could be restored for service. The survey teams faced a nightmare environment. The water was thick with leaked fuel oil, forming a toxic sludge that coated divers and equipment. The visibility was near zero. Inside the wrecks, the hazards were magnified. The interiors were tangled mazes of floating debris, smashed furniture, and twisted metal. The seacocks opened by the French were still open, connecting the interior of the ships directly to the sea. The Italians categorized the victims. The capsized destroyers were largely written off as total losses, destined to be cut up where they lay for scrap metal. Their structural integrity had been compromised by the roll, and righting them would require leverage that the mud bottom could not support. But the upright battleships and certain cruisers presented a different equation. Strasbourg sat broad and level on the harbor floor, her hull still true enough to work with. On the salvage ledger that made her worth a resurrection, the salvage engineers began to draft plans for a resurrection. They would not merely cut Strasbourg apart. They intended to make her float again. This decision shifted the operation from simple harbor clearance to complex combat engineering. They would have to fight the water pressure, the mud suction, and the sabotage left behind by the French crews. Sinking had taken nothing but gravity. Recovery would mean sealing openings, breaking mud suction, and pushing back against the sea's pressure. You don't hoist a battleship like cargo. You make her watertight again, then drive the water out until buoyancy does the lifting. For Strasbourg, that meant one thing first: stop the sea from spilling back through every exposed opening. Their primary tool was the cofferdam. A cofferdam is essentially a watertight extension built around a submerged opening. When a ship sinks in shallow water, parts of the deck and superstructure may sit close to the surface. If pumps begin removing water, the sea can simply spill back in through exposed openings. The cofferdam solves this by extending those openings upward, artificially raising the freeboard above the waterline. Divers descended into the harbor mud to bolt these timber and steel structures around the hatches, barbettes, and companionways of the battleship. It was a tedious, exhausting process. They worked by touch in zero-visibility sludge, packing joints with sealing material to keep the barrier tight. Once the cofferdams breached the surface, the sea lost its easiest path back in. Simultaneously, the salvage teams used a mix of pumping and compressed air dewatering. In some compartments, pressurized air could push water out through existing openings, acting like a temporary air pocket inside the hull. Done carefully, it added buoyancy deep inside the ship and reduced the load on pumps. It was a delicate balance. Pressure had to be controlled to avoid worsening structural damage, while still coaxing the water to retreat. While the engineers battled the physics, the Italian Naval Command revealed its intent for the French fleet. They did not view every hull as scrap. In a bureaucratic act of possession, they began to rename selected vessels on their registers. The French cruiser La Galissonière was listed as FR-12. Jean Dufresne became FR-11. Other captured destroyers and submarines were similarly rebranded with an FR prefix, followed by a number. It was possession in ink, names erased, numbers assigned, and a future being tested on paper. By mid-1943, the combat engineering effort reached its dramatic moment. After months of sealing, patching, and dewatering, the pumps and compressors on the Strasbourg were brought to full power. Slowly, the 26,000-ton battleship broke the suction of the harbor mud. The muddy water churned as the hull rose inch by inch. For the first time since the previous November, the main deck of the flagship dried out in the Mediterranean air. The operation was a triumph of salvage skill, but it was not a return to combat power. The Italians could reverse the flooding and make Strasbourg float again. Restoring a scuttled battleship to true readiness was a different order of work. Strasbourg was towed to a nearby fitting-out berth, awaiting an assessment and repairs that might, if time and resources held, return parts of her capability. But the salvage teams were racing a calendar they could not control. The political foundation of the operation was crumbling even as the ship rose from the depths. September of 1943 brought a reversal that no naval architect could have calculated. The Italian government surrendered to the Allies. Overnight, the salvers became the enemy. The engineers who had painstakingly raised the Strasbourg down tools and fled or were detained. The German military, which had stood on the pierheads watching the fleet sink 10 months earlier, now seized total control of the harbor. This was the decision flip. The assets that the Italians had treated as the nucleus of a new navy were instantly reclassified by the German High Command. In Berlin's eyes, they were simply hulls to be accounted for. The German Navy, the Kriegsmariners, boarded the newly refloated vessels to assess their combat potential. What they found was a testament to the effectiveness of the original French sabotage. While the Italian divers had successfully defeated the water, they had not defeated the sabotage in the propulsion train. Strasbourg was dry and floating, but she was paralyzed. The reduction gears were still wrecked. Fixing that kind of damage would have meant diverting scarce alloy steel and precision machining from fronts the Reconstructing could not abandon. In the southern theater, no one was going to cut new giant gears for a captured French battleship. That renamed fleet existed only on paper, and it vanished. The German strategy shifted instantly from resurrection to consumption. The ships were downgraded to two categories: sources of raw metal or static defensive implements. This marked the beginning of the blockship strategy. A blockship is a vessel whose final value is derived not from its ability to float, but from its ability to sink in a very specific location. In naval warfare, a harbor is only as useful as its entrance channel. If a defender can position a large, heavy obstruction in the narrowest part of that channel, they can deny the enemy the use of the port facilities. The ship becomes a massive, underwater concrete wall. The Germans began to maneuver the refloated hulls with this grim utility in mind. They stripped usable anti-aircraft guns and smaller fittings, cannibalizing the Strasbourg and La Galissonière to fortify their shore batteries. The great battleships were reduced to floating stockpiles. The logic was cold and binary. If the ships could not sail to fight the Allies, they would be sunk to stop the Allies from landing. This pivot created a strange stasis in the harbor. The ships were technically saved. They were largely pumped out and sitting high in the water. But they were hollow shells, devoid of political purpose or mechanical life. They drifted at their moorings, waiting for the final execution order. The Germans prepared to tow them into the channels at the first sign of an Allied amphibious assault. However, the Allies were watching. Aerial reconnaissance photographs revealed the activity in the harbor, and analysts saw the danger forming in the channel. A battleship used as a plug. If the Germans managed to scuttle Strasbourg across the main channel, it would choke the logistical flow needed for the liberation of France. The decision was made to intervene. If Strasbourg could be dragged into the fairway, Toulon's port would die behind her. So the countdown began. By mid-August 1944, the timeline for the German occupation of southern France had shrunk to a matter of days. The Allied invasion force, Operation Dragoon, was already at sea. The strategic imperative shifted from long-term asset denial to immediate tactical clearance. The fear was no longer that the Germans would use the Strasbourg as a battleship. The fear was that they would use her corpse as a gatekeeper. If the Germans succeeded in towing the 26,000-ton hull into the main fairway and opening the valves, the harbor would be sealed. The Allied logistics chain, desperate for a deep water port to supply the drive north, would be strangled. The United States Army Air Forces were given a precise task: sink the French fleet before it could be moved. On the morning of August 18th, the solution arrived in the sky above Toulon. It came in the form of 36 B-25 Mitchell bombers from the 321st Bombardment Group. These were medium bombers designed for low-level precision strikes against bridges and transport hubs. Today, their target was a stationary battleship that had already died once. The raid was surgical by the standards of 1944. The bombers did not carpet the entire harbor. They focused their sights on the refloated Strasbourg and the cruiser La Galissonière. There was no anti-aircraft fire from the ships themselves. Their guns had been spiked by the French or stripped by the Germans. The vessels sat defenseless, tethered to the quays, waiting for the impact. The bombardment was brief and violent. High explosive ordnance smashed into the superstructure and decks of the flagship. The goal was not to detonate magazines, as they were likely empty, but to compromise the watertight integrity of the hull. The bombs punched through the steel plating, reopening the wounds that the Italian divers had spent months patching. The sea rushed back into the spaces that had been so carefully dewatered with compressed air. For the second time in 2 years, the Strasbourg began the slow, agonizing descent to the bottom. This time there was no crew to open the seacocks and no crew to close them. The physics were purely kinetic. The blast damage overwhelmed the residual buoyancy. The battleship settled back into the mud, listing heavily but remaining largely upright. Nearby, the La Galissonière suffered a more violent fate, capsizing once again under the force of the explosions. This event completed a rare and paradoxical cycle in naval history, the double scuttle. The Strasbourg had been sunk by her French owners to deny her to the Germans. She had been raised by the Italians to serve the Axis. And finally, she was sunk by the Americans to ensure she could not be used against the liberation of France. The destruction of the refloated fleet removed the last tactical card from the German hand. With the ships pinned to the bottom, the threat of a blockship obstruction was neutralized. The Germans could no longer tow the heavy hulls to the channel entrance. The harbor entrance remained technically open, though cluttered with debris. When the Allied ground forces liberated Toulon shortly after the raid, the harbor felt like a rewind of 1942. Masts still clawing above the surface, hulls still pinned in the mud. But the meaning had inverted. The ships were no longer prizes to be won. They were wreckage to be cleared. The salvage cycle had moved from rescue to demolition. The war was moving north, leaving the shattered fleet behind in the silence of the mud. The question that defines the legacy of Toulon is not about valves or gears. It is a question of the alternative. If the fleet had attempted to break out of the harbor on that November morning rather than scuttling in place, the outcome is still debated. The distance to Allied safety in North Africa was not great, but Axis air power and coastal forces made any dash a high-risk gamble. A breakout might have saved a few hulls, or it might have ended in heavy losses at sea. The decision to scuttle was a choice between uncertainty and certainty. By sinking the ships at their moorings, the French Navy achieved its primary objective: denial. In the years following the liberation, Toulon stopped being a battlefield and became an industrial problem. What remained was a clogged, dangerous mess that had to be cut away, one section at a time. The French Navy, attempting to rebuild its strength in a new era, had little use for waterlogged, sabotaged hulks. The battleships that had been the pride of the pre-war fleet were now merely obstacles to navigation. The clearance operation was long and unglamorous. Salvage firms moved in with cutting torches and cranes, patching hulls only enough to move them to the breaker's yard. Strasbourg, having died twice, was raised for a final time, not to fight but to be fed into the furnaces of post-war reconstruction. The steel that had been forged to protect French sovereignty was melted down to build the infrastructure of a new republic. This unceremonious end underscores the unique tragedy of the event. In most naval disasters, the loss of a ship is an accident or a defeat. At Toulon, the loss was the strategy. The engineering skill displayed by the crews was not used to keep the ships afloat, but to ensure they sank efficiently and irreversibly. Reduction gears torched, gun barrels ruined. The vandalism was precise. They ensured that even when the Italians applied the laws of physics to raise the hulls, the ships remained ghosts, hollow and useless. The outcome of this massive destruction falls into a gray area of military success. The French fleet did not survive to fight for the Allies. It did not sail in the grand reviews of the victory. In material terms, it was a total loss, a self-inflicted catastrophe that erased centuries of naval tradition in a single hour. However, the strategic ledger tells a different story. The Axis powers, despite their occupation of the harbor and their salvage efforts, gained almost nothing from the prize. They spent precious resources raising ships they could not repair, only to have them bombed by the Allies before they could be used. The operation remains a case study in the power of denial. It demonstrated that a navy does not need to fire its guns to affect the course of a war. Sometimes the most damaging thing a fleet can do is simply remove itself from the board. The 77 wrecks at Toulon served their purpose by doing absolutely nothing. They sat in the mud, consumed enemy resources, and blocked the channel, proving that in the calculus of total war, a dead ship can be just as dangerous as a live one. The harbor water eventually cleared, but the echo of that morning did not. Steel can be cut, raised, and melted down. Intent is harder to dismantle. In Toulon, a fleet altered the war by removing itself from the board, and the silence of that decision remains.